All right, good evening. Welcome back to PreCalculus. We are talking about the polar form of complex numbers. All right, so here we go. So the first one is number 4, by the way. So number 4. We are going to find the modulus of each complex number. Forgive me, I'm going to go ahead and draw this first so that we can see what the heck we're talking about, because I always go back and make this thing into a triangle because that's what they are. Okay, so if I wanted to graph this thing, got some experience in the last couple of problems. 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3. This is the imaginary part. This is the real part. Okay, so we're 7 and 3. So what I want to know is this is 7 plus 3i. What is the absolute value of 7 plus 3i? What is the distance between the origin and this point here? Okay. So this is a triangle. It's a right triangle even. So we could go ahead and use Pythagorean theorem. So we're going to say, well, c squared is equal to the square root, or actually just c, not c squared. C is equal to the square root of 7 squared plus 3 squared. Okay. You don't have to include the I. That's the direction that we're going in. Okay, that doesn't count for like the modulus here. Okay, so we get a 48 or 49 plus 9, 3 squared 9. Right, and it looks to me like it's 58, so let's double check. Okay, so we have 49 plus, there we go, come on. 49 plus 9 is 58. Of course it is. And I was kind of hoping, I was like, that's close to 60. Like, that's not divisible by 4, is it? So we're going to divide it by 4 just to check. It's not divisible evenly by 4. So is it divisible by 9? It's certainly not. So it's not divisible by 1, 4, 9. What's divisible by 1? But 1, 4, 9, 16, 25. So what I'm doing is I'm fishing for perfect squares to see if I can fish a perfect square out of this to make this a little bit, to make this reducible. I don't think there is. Okay, I think I'm just kind of stuck with 58. We could try 2, but I didn't see anything. A few times 29. That's not a perfect square. So the modulus is just going to be the square root of 58. That's really all we could do with that. Okay, so we'll go ahead and get our green light here. Let's see if they're going to do that yet. Oh, killer. Figuring out all the empty boxes. All right. So this one is negative 10 plus, what is that, 31i. That seems painful to have to go ahead and graph. So here we are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then for up, we have 1, 2, 3, 4. Actually, you know what? Let's do 10, 20, and 31. Okay. 2, 3, 4, 5. We'll call that 30. So it'll be up here somewhere. Okay. So I went negative 10 and then plus 31. So it's going to be up here. Okay. So we have to figure out this modulus here. What is the absolute value of negative 10 plus 31i? All right, and we'll just go ahead and do that. We need a hypotenuse. So it's c is equal to the square root of 10 squared. Technically, I guess negative 10 squared plus 31 squared. Best of luck for that one. I am not going to be able to figure that part out. So we have 100 plus, I have no idea what 31 squared is. That's okay. Okay, so 31 squared is 961. And then we're going to add 100 to it. That's going to be like 1061. Okay, so we're going to add 100 to it. That looks like 1061. Let's see, that's 6, 7, 8. That's not divisible by 9. They have to be divisible. They just have to add up to 3 for that to work. So that's not divisible by 9. So let's see if we can do that. It's clearly not. We'll go ahead and add the 100 in there. Okay. So 6, 7, 8, that is not divisible by 3. It's not divisible by 9. It's not divisible by 4 because it's not even. It's not divisible by 5. I don't think we have too much of a thing to do here. Okay. Technically, we can do, Aristotle's awkward. Go up to whatever the square root of this is to see, to check. Okay. Um, let's see, 6 squared is, or sorry, 5 squared is 25, 6 squared 36, not divisible by 36. 7 squared 49. Let's see if it's divisible by 49. No, no, it isn't. Okay. So not divisible by 49. Okay, let's see. That's 7 squared, 8 squared. It's not divisible by 64. 9 squared would be 81, not divisible by 3, so it's not divisible by 81. So there we are. Maybe let's try 11. Let's try divide it by 121, see if that works. Nope. And that's pretty much as best as you're going to get because we have to go up to effectively the square root. Okay, so let's divide by 11 and then multiply by 121. Get back what we started with. Okay, 1061. So I didn't see that it was divisible by any perfect square, so I think we're just stuck with 1061. So we'll go ahead and see if the computer yells at us or not. 1061. We'll go ahead and check. And it didn't flag it saying, hey, you should reduce this. Like, we didn't have to worry about that. So they just gave us the green flag and they said, go on with your life. So that's number 4. That's what we're doing with that one. Okay. We'll do a little bit more next time. So thank you for tuning in, and I will see you in the next video. Thank you.